Good morning. Today we will discuss about rational and irrational numbers. So, what is a rational number? Have you heard about rational number? Okay. Rational numbers is the combination of three different words like ration, all, numbers. What is a ration? A ration is nothing but ratio. All. All stands for of numbers. So rational numbers is nothing but ratio of numbers. That means if you write a number in the form of a ratio or fractional form, it is considered as a rational number. A number which can be expressed as a fraction in its lowest form is called a rational number. A number which can be expressed as a fractional form or p by q form. Okay, example 0.5. We can write 0.5 as 5 by 10. In the lowest form it is 1 by 2, as we are able to divide it by 5. Another example 0.25 can be expressed as 25 divided by 100. Yes, but it is not in its lowest form. So to make it as in the lowest form, we can divide both numerator and denominator by 25. So we get 1 over 4, which is a rational number. Types of decimals. Mainly, there are two types of decimals. Means decimals can be divided mainly into two types. They are terminating decimals and non-terminating decimals. So decimals are divided into terminating and non-terminating. Terminating decimals are having countable number of digits after the decimal point or finite number of digits like 0.5, 0.25, 2.3669, 3.56565656, etc. are a few examples of terminating decimals, as they have finite number of points decimals. We can count the number of digits in terminating decimals. Okay, but when we consider a non-terminating decimals, they have infinite number of digits. Okay, or decimal part continue forever can be considered as non-terminating decimals. They never end, they goes up to infinity like 0.222 etc. Or if we consider 2.36363636 etc. or the value of pi like 3.1416 etc. 2.35685468214563 etc. These all are non-terminating decimals. Okay, and when we consider non-terminating decimals, it's divided into two types. There are two types of non-terminating decimals. Do you know what are they? Okay, they are recurring decimals and non-recurring decimals. They are recurring decimals and non-recurring decimals. Okay, so non-terminating are recurring and non-recurring. Recurring means repeating. Okay, so when we consider a recurring decimal, what do you mean by recurring and non-recurring? It's very simple. Recurring stands for if the digits are repeating uniformly. See this example here, 2.323232 etc. After the decimal point, see the digits, they are repeating uniformly so that you are able to identify the next digit. Can you say what is the next digit? Yes, it is 3. So what will be the next digit? It will be 2. We are able to identify the next digit. Okay, like 23.564, 564, 564, etc. You could find a uniform repetition of digits. They are recurring. But when we consider some examples like 2.35653458975 etc., there is no uniformity in the arrangement of digits, so we won't be able to identify the next missing digit. Will be no. Such decimals are known as non-recurring decimals. This non-recurring decimals comes under the number system irrational number. So such numbers are irrational numbers. We discuss that later. Okay, so now our main topic is non-terminating recurring decimals. As they are rational numbers, we'll be able to convert them into the form of a fraction. When we consider a few examples on the screen, the first example is 0.33. Only one digit is repeating here. So it can be written in a short form as write that repeating digit and just place a dot on that. So it will be 0.3, a dot over it. Now in the second example, two digits are repeating. They are 25. So write 0.25 and dot on 2 and also on 5. In the third example, 3.568 etc. There 568 is repeating. So we can mention it as 3.568 and a dot on the first digit and also the last digit. No need to put on all the three. Okay, now let's consider one example. Write the following recurring decimal as a fraction. 0.5 dot over it. Okay, so let's expand 0.5 a dot over it. Okay, you know 0.5 a dot over it is equal to 0.5555 etc. Isn't it? Okay, because it is a recurring decimal. The dot shows that it is a recurring decimal and which digit is repeating. Okay, now what's our method? So for our topic is to convert it into a fractional form. So our first step is assume this recurring decimal as x. Okay, so assume x is equal to 0.5555 etc. How many 5s you want, you can arrange, no issue. Okay, this assumption let's name as number 1 for our convenience. Okay, so the next step is check how many digits are repeating. You can identify only one digit is repeating. Which is that digit? Yes, number 5. So how many digits, which number or which digit is repeating doesn't matter. You need to check how many digits are repeating. Only one digit is repeating here, isn't it? So based on that, we are going to find a number. As only one digit is repeating, let's multiply equation 1. Equation 1 is that assumption part with 10. The 10 is meant for 1 0 number. Okay, because as one digit is repeating, multiply is with the 10 number. 10 number is 10. If there are two digits repeating, multiply with 100, etc. like that. So equation 1 should be multiplied with 10. We get LHS as 10x is equal to, in right hand side multiply 10, we get 10 into 0.555, etc. So what will be the next step? We get 10x is equal to, when you multiply a number with 10, you know the decimal moves one place to the right. So the decimal point moves one place to the right side. It moves one place to right, and the result becomes 5.555, etc. Did you get what is meant by that? So nothing, multiply a 10 on both sides so that we get 10x is equal to 5.555, etc. So this should be considered as number 2. Okay. So number 1 is x is equal to 0.555, etc. And number 2 is 10x is equal to 5.555, etc. Now our next step, that is third step, is subtract these two numbers, these two forms to be subtracted. That is equation 2 and equation 1 should be subtracted. Okay, that is equation 2 minus equation 1 to be done. When we do this subtraction, we get the corresponding result for x, because here x is our result. As we assumed x is equal to 0.555, x will be the result for us. Let us subtract. Write the second equation, 10x is equal to 5.555, etc. minus the first equation. First equation is x is equal to, see how we are writing exactly down of x, we are writing the next x also, 0.555, etc. Okay, write it as normally so that we can subtract it easily. Just decimal to be written one by one down so that it will be easy to subtract. Now do the subtraction. Okay, it's very normal subtraction. You know how to subtract 10x minus x. X is same as 1x, so 10x minus x is 9x. And when you subtract the right hand side, we get 5 minus 5 is 0. Just normal subtraction. How do you subtract two numbers? That you have to do. So that the right hand side answer is number 5. So the answer is 9x is equal to 5, or x is equal to 5 over 9 as a result. As 5 over 9 is in its lowest form, we cannot simplify it, so that will be the final fractional form of 0.5 dot. Okay, another example, 0.618, and the dots are for 6 and 8. That means what you can understand, 618 is repeating, so write it in expanded form. Now do you remember what we have to do? Yes, so step 1 is assumption. Assume that 0.618, 618, 618, etc. as x. So we get x is equal to 0.618, 618, 618, etc. And let us consider this one as equation number 1. Okay, this equation 1, equation 2, they are just for our convenience. Okay, so here 3 digits are repeating, isn't it? 618. is repeating. So multiply equation 1 with 30 number. What is that? 1000. Multiply equation 1 with 1000. So we get 1000x is equal to 1000 multiplied by 0.618, etc. Yes. Is this equation number 2? No, it is not equation number 2. Is it equation number 2? No, it is not equation number 2. Why it is not equation number 2? Because we haven't done the multiplication. Okay, so multiply 1000 with the decimal. What happens to the decimal point? It moves 3 places to the right. It moves 3 places to the right. So that we get the result as 1000x is equal to, when it moves 3 places to the right, we get it as 618.618, etc. Okay, this is equation number 2, not the previous one. Okay, so we have done second step also. First step is assumption, second step is multiplying 10, 100,000, etc. Third step is subtraction, equation 2 minus equation 1. Okay, we are doing equation 2 minus equation 1. I have written 1 and 2, it's wrong, it is 2 minus 1. Okay, we are doing 2 minus 1 because 2 is the bigger one, that's why. So 1000x minus x is 999x. And when we subtract the right hand side, you just do the normal subtraction, digit by digit subtraction, so that we get the result as 618 in the right hand side, 618 as a result. Yes, so we get 999x is equal to 618. That means x is equal to 618 over 999. Now we got the fractional form, but it is not in the lowest form because both are multiples of 3. Yes, to check the multiples of 3, use the divisibility test of 3. Okay, so both are the multiples of 3. As they are the multiples of 3, divide numerator and denominator by 3. So we get 206 as the numerator and the denominator is 333. Okay, so the result is 206 over 333. Got what we have to do? Now that is in lowest form. Okay, thank you.